Hello everybody, my name is Zoltán Vinaj. I am a structural engineer and the CEO of Lapidarium Engineering Ltd. We are located at Budapest, Hungary. We are doing structural design mainly, but due to our environmental cautiousness, we are assessing this carbon footprint issue too. And here we are dealing with embodied carbon, not operational carbon, but embodied carbon itself, and not just for the structures. However, we assessing it on a shell level. This means that we include in inventory the structures itself, the foundation, substructures, superstructures, and also the non-load bearing elements such as partition, walls, screeds, insulations, facades, doors, windows, all this stuff. So basically today I would like to show you our latest project. It was a semi-high-rise building, monolithic concrete structures. It is going to be built on the bank of the Danube River. The design it as at the concept level right now. The building has a two-story, two-level basement, the parking lot below the ground level, and has 21 level superstructure. The superstructure, it has a concrete wall, load-bearing elements. At the first and the second story we have columns, load-bearing columns. Everything is the monolithic concrete in this building. The GIA is the gross internal area for the building is 23,000 square meter. It's a relatively large building. So how did we do this analysis? First, we've done an inventory in a spreadsheet. You can see here we have listed all the elements which is needed to construct this building, and we have the categories according to OneclickLCA. This is a software we are using for the analysis. So you can see here all the items and the amounts of the items and the qualities, the grades. So it is listed. It's very much similar to the cost calculation of a building, but we have different categories here. So once we have done with it, we went to this OneclickLCA software. What is basically the software does, it connects every process and material amount to carbon emissions. And the way it connects it uses an environmental product declaration database, which actually tells us, for example, certain materials, what is the environmental cost to produce that material, and all this expressed in a carbon dioxide, equivalent carbon dioxide amount. So what we have done here, we just imported all the data here, and you can see here building materials, and it is categories, and the program calculates the carbon dioxide emission related to a process or the material instantly. So you can check what is the portion of the emission even in the project itself. So once we have done with it, we can see the results. What is the carbon emission of the building? Embodied carbon emission. You can see here results, here view results, yes. So the building itself accounts for over 9,000 tons of carbon dioxide emissions. It is a point of view that it is large or not. Let's say if we see that Hungary, each person in Hungary accounts for 5 ton carbon dioxide emission in annually, then it is about that the building is equal, the building carbon dioxide emission equal to 2,000 or 1,900 person's emission annually. It's relatively not too high. And also, if we compare it to the annual emission of Hungary, which is over 48 million tons, it is almost nothing. But of course, it tells us not too much about the building environmental quality. So how can we judge this building? First of all, we have to have a number which is based upon we can make the benchmarking, and this is the carbon dioxide emission per square meter. And here you can see this building has a 365 kilogram per square meter carbon dioxide emission, which is in this benchmarking you can see it is level C. It is quite an average or better than average. In Hungary, this program has 25 sample size, so it's not a really large one. In Lapidarium, in our firm, we've done 8 analysis so far, and this number is a good one, I would say. And how can we assess this number in a better way? We can find benchmarking which is recommended by LETI. This is a voluntary network called London Energy Transformation Initiative, and they've prepared this embodied carbon target. You can see here. Here in the upfront carbon for residential buildings such as ours, it says that this 360 is somewhere between A and B, but it must be kept in mind that there are other. We did analysis on shell level, not on core level, not on shell level, and the difference is about, in our case, it's about 20-30%. So this building is not AB, but rather than C or B, rather C. And here you can set a target, and you can find that you can try to make a better solution for your building, and then you can measure that what classification you have reached with this building. Let's see that what are the part of the results here. Here, view the results. So the most contributing materials, of course, the concrete and the reinforcement. Altogether, they account for over 80% of the carbon emission. And then comes the screed, and then the 3% the laminated glass, which is the parapet wall on the open balconies, you know. So here you can see that we have some diagrams here. Materials, the construction materials accounts for 80% of the carbon emission. All the other parts like construction, demolition, waste processing, transport, all this stuff, it's about just 20%. Here you can see again that no, this is a new one. Its external walls are dominating here because of the building has a concrete wall structure. We have walls, the external walls and internal walls everywhere. So just it means that that's why it has so large contribution. And here, materials, the contribution of different materials again. Concrete and metal, the reinforcement accounts it's over 80% of the total amount. So it's just a large part. Let's see how can we improve this design. Naturally, it's not a wonder, but we should reduce the carbon emission from the production of the concrete and the reinforcement too. In Hungary, we have about 80, not 80, but sorry, 60% recycled material in reinforcement steel. In England, it is 100%. So if we get a better contractor who can have this higher recycled content, that should we use it. And also we should use cement which has higher GBC, I mean materials which substitute cement, because cement is the most contributing materials in carbon emission. So if we, for example, we are able to replace the cement by 50%, then using SAM2 cement type, then here you can see I have created an alternative design of the building. So just by replacing the concrete with a more friendly, environmental friendly concrete, and also we are using 100% recycled steel, the carbon emission related to this building is reduced by 40%. This is very large percentage. And above this one, we should also make a smarter design. We use smaller structural sizes, and and we can reduce other non-structural elements contributions too. So these should be the next steps in our further design stages. Thank you for your attention. Bye-bye.